everybody. Let's take a look at the Doppler effect.
It's the apparent change in the frequency of a wave caused by relative motion between the source of the wave and the observer.
So, as Sheldon has said, it refers to the change in a wave frequency during the relative motion between a wave source and its observer. To fully understand this concept, we first have to go into a wave. And what is a wave? A wave is defined as a disturbance that travels through a medium. We find that waves exist as sound wave or as light waves. Let's look at an example to further explain this. Here we have a puddle of water, and we have a drop of water falling into this puddle. As we all can see, when the drop falls into the puddle, it sends out a ripple effect. The puddle of water acts as a medium, and the single drop falling in acts as the disturbance. Now knowing this, let's dive into understanding Doppler effect. We find here that a single source sends out sound waves into the air particles by the example of an ambulance and its siren. Now let's see what happens when the ambulance starts to move. The ambulance moves toward the left-hand side, and as we can see using the arrow, in front of the ambulance, the waves are now compressed. As the ambulance continues to move to the left-hand side, look behind the ambulance, where the arrow is pointing. Those wave fronts are now more spread out. How do these wave fronts now affect the loudness of a sound? We find that when waves are created, it also creates an amplitude, and the greater the amplitude is, the louder the sound would be because it has more energy, and the lower the amplitude is, the softer the sound would be as it has lesser energy. So, the longer the wavelength we have, the lower its amplitude will be, and the softer the sound we would hear. If the wavelength is shorter, we will have a high amplitude, which will result in a much louder sound. Now knowing this, we can see that when this ambulance moves forward, the wave fronts in front of them become compressed. This results in a shorter wavelength, and a shorter wavelength will have a much louder sound. The Doppler effect is a physical quantity which can be calculated using this formula. Here we find different variables that can be calculated, such as observed frequency, actual frequency, or velocity. We find that we have the following explaining what each part is. We have the observed frequency, the actual frequency, the velocity of sound waves, velocity of the observer, and the velocity of the source. Now, where can we actually use this Doppler effect? The radar gun. The radar gun is used by many police officers to try and get an idea of what speed a car is traveling at. The radar gun sends out waves, and the waves bounces off the car. The waves then return to the radar gun, where the velocity of the car is actually calculated. By doing this, the police officers are able to determine if the person driving has been speeding or not. Another example of where the Doppler effect is used is in the medical industry. By using the Doppler echocardiogram, we find that this machine can use the Doppler effect to determine the blood flow in a human being. By doing this, doctors are able to determine if there are any blocked arteries or valves within a heart of a human being. The Doppler effect is also used by meteorologists when determining weather patterns by using the pulse Doppler radar. The pulse Doppler radar sends out waves into the atmosphere. If there are any droplets in the atmosphere, the wave front then bounces off this droplet and returns to the radar. The radar is then able to determine how far away this precipitation actually is, and that is how we have our weather predictions that are formed. We find the Doppler effect has uses in various parts of our industries. One of my most favorite ones, however, is the Doppler effect with the stars. So how can the Doppler effect be used in stars? It's two phenomena. One is called a redshift, whilst the other is called a blue shift. We basically study the wavelength of a star according to the color observed. And by using this color observed, we're then able to determine if a star is moving toward us or away from us. So when looking at light, we find that a blue light generally has a shorter wavelength and a higher frequency, which means the object is coming toward us, while a red light has a longer wavelength and we find it moves away. So, when you look at a blue light, it actually means the wavelengths are much shorter and the object is closer. And looking at a red light means the object is further away. This leads to our two phenomena, our blue shift and our red shift. A blue shifted star means it's coming toward Earth, and a red shifted star means it is moving away from Earth. So, when you look up at the night sky and if you see red stars, what it's basically telling us is this star is actually moving away from Earth, because the red light gives us longer wavelength, and a longer wavelength means a greater distance. So, the next time you look up at the sky, observe. Do you see more red stars or more blue stars? Scientists have observed much more red stars in the sky than blue stars. And by this observation, they have come to the conclusion that our universe is actually expanding.